I'm Abe Peck, Editor-at-Large at Inside Unmanned Systems, and we're here with Jaysen Yochim, who's Senior Director for Aerial Logistics Program at Airbus. And we're going to talk about a truck that flies, I'll call it, the MQ-72C,
yes.
Lakota. Right.
Correct.
So tell us about it.
So the MQ-72C Lakota Connector is a program that we're in right now with the Marine Corps. It's a mid-tier acquisition rapid prototyping competition that we expect to down select for that around this time next year is what we expect. Really what we're trying to do is, as I describe it, we're building a truck for the Marine Corps that we're opening up the entire cabin of the aircraft that's based on the UH-72 Bravo, which is already in service with the Army. We're opening up the entire cabin, we're moving the crew station, and we're putting as much autonomy as we can inside of the aircraft. Man is always going to be in the loop at some point, but we're trying to offset the man in the loop as much as we can, based especially on the lower density population that the Marine Corps has. Because they have such a low population of troops, they're always trying to be as efficient as they can with how they do, as we call them, the military troop to task.
Right.
And so we're trying to maximize the use of autonomy wherever we can to reduce their workload.
So what do you see, you mentioned the Army, you mentioned the Marines, what do you see as this drive toward, I'm interested in helicopters, toward autonomous helicopters? So what's the mission, why, Well,
I think that there's different aspects to it. I think that if you look at helicopters in general, it's a very intensive aircraft to fly. I flew Apaches in the Army for 27 years, and so it's flying helicopters is not easy, and it takes a long time to train pilots up on how to fly helicopters. It's also can be expensive to train pilots, and retaining them becomes a whole nother piece of it. And the other piece that comes with an autonomous system, when you look at unmanned aircraft, what they frequently try to use unmanned aircraft for are the 3 Ds, the dull, dirty, and dangerous missions. And when you're trying to get after the dull, dirty, and dangerous missions, having an unmanned aircraft that's delivering logistics, which is what we're really going for, it can be constantly just moving supplies back and forth between locations, and you don't have to worry about crew rest, you don't have to worry about the normal things that humans have to deal with going to the bathroom and things like that. They can just constantly be doing those rotations back and forth, which as a dull mission can cause some pilot issues as well, where you're not paying as much attention to what you should be doing sometimes. So it takes that out of the loop, and so it simplifies it. It's less pilot workload. It's less load on the Marine Corps to be able to do it, and in the end, it's an efficient way of moving supplies.
But you said there will be a human lurking. How much?
So our plan right now, there's never going to be a human completely out of the loop. We think that at some points in the mission, especially if it's taking off and landing from the base area, whether it's on a ship or in a FOB type location, I think there's going to be some positive control over the aircraft. So you'll actually have a trained UAS operator that's going to be operating the aircraft. Conversely, when you're flying this aircraft to some of the remote locations, one thing that the Marine Corps is really talking about a lot right now is that every Marine a UAS operator. If you go with that every Marine a UAS operator, that implies that when you send it out to these remote locations to drop off supplies, there has to be an intuitive way that they can communicate with the aircraft. So in addition to a traditional ground control station that we're building that's going to have more higher levels of control, at the point of destination, we need to have something that's more of a man-portable, tablet-based or something like that way, that a Marine that doesn't have a whole lot of education on how to operate UAS can have simple controls to tell the aircraft what to do, but having the autonomous brain on the aircraft going through the actual, what does it mean when the kid with the tablet says, land at this location, what does that mean to the aircraft? And that's where the autonomous behaviors that we need to build as well.
If you had to isolate a couple of key technology elements, for this, it works, for this to fulfill its mission, what would you say are the key ones?
I'd say the biggest one is autonomy. Autonomy, it's growing quickly. I think that as an industry, autonomy may not be where it needs to be right now. But when you start building out those autonomous behaviors, it's something that I think that over the next 4 years, which is really the lifespan of the MTA, we're going to see what autonomous behaviors can do. accelerate over time, because it's just like Moore's law. You know, the more time that happens, the better autonomy is getting. I think the autonomy systems that we see 4 years from now are going to be much more advanced than the autonomy systems we're seeing now.
And let me switch you over. At this kind of show, what are you trying to convey?
So part of this show, I mean, there's a lot of business-to-business discussions happening at this show. There's a lot of innovative different companies that are here. You know, some of the things that we're going to need on the aircraft, we know we're going to need sensors on the aircraft to be able to inform the AI brain that's on it.
Right.
There's a lot of great companies that are here. We're still figuring out what that sensor package needs to be. We think that there will probably be a mix of EOIR, radar, and some kind of LiDAR, but we're not set on what that needs to be yet. And we also have to be conscious of the environment that we're operating in. It's going to be a highly contested EW environment. The aircraft needs to be able to operate in a environment where it may not constantly...
Everything denied environment.
Everything denied. And so that's really goes into the autonomy. It's not just protecting the aircraft, but having an autonomous system that's resilient enough that it can continue if there's interruptions in that frequency.
Great. So anything you want to add?
No.
Great. Well, listen, I wish you luck with the project, and it sounds great. And I'm always in favor of flying trucks. So thanks a lot for stopping by.
All right, great. Thank you.